the IGNOU website. It talks about discharge measurement in streams, and the space is those who are from Roorkee, they are aware of this one. It's a canal, old canal.
Is an essential commodity for all living organisms. To make it available to every user, management of water is a must. For best utilization of water resources, various multi-purpose projects are in use.
These projects include irrigation, flood control, power generation, and navigation. For these purposes, a correct and accurate assessment of water availability in time and space and methods of efficient use of water are very important from both technical and economic points of view. The demand for accurate assessment of water resources is increasing with increase in population. The flow measurements are also necessary for sharing waters between different states or countries, and also for distribution between different headworks and canals. Therefore, reliable and standard measurements of water flow or discharge in rivers and other open channels are of vital importance. To measure the discharge, area velocity method is commonly used. In this method, area of the flow section and the average velocity of the flow are determined at a particular location. The discharge is equal to the product of these quantities. This method is based on the principle of continuity. For this area velocity method, a location is identified, keeping in view that there should be an adequate straight reach having streamlined flow. It means location should be away from curves and there should be no turbulence. The site should also be away from any large structure which may affect the flow pattern. Stream bed should be stable and free of large deposits and weeds. This location under the bridge, away from the curve, having straight reach, is an ideal location for discharge measurement in this canal. Similarly, it is a good location in the river, and here measurement can be made by the boat. When velocities are excessive, or when the riverbed is irregular in mountainous regions, a trolley is used along a wire drawn between the two banks. To know the area of the cross-section, width and depth are to be measured. The depth of the channel bed may vary along the width of the channel or river. Therefore, the stream is divided into a number of observation verticals in such a way that the discharge between two consecutive verticals should be less than 10% of the total flow. The spacing between the verticals is reduced if the bed profile changes greatly across the river, though it is convenient to make the verticals equidistant. For measuring the distance of the verticals from the bank, rope and tags are used. When the river is too wide and deep, the method of triangulation is used to establish the verticals. For this purpose, the property of similar triangles is used. This distance corresponds to river width, and it can be divided into desired number of verticals. At sight, the boat is brought on a cross line perpendicular to the river flow with the help of a pair of poles. Now the ranging is done to bring the boat at the desired vertical. Theodolite is also used to establish the verticals. After establishing the verticals, the depth is measured. The sounding rods are used to measure the depth, where bed is not too deep. In deep channels, depth may be measured by metered cable, to which a heavy weight is attached. Another reliable device is the echo sounder. It measures the time taken by the sound waves in going to the bottom and coming back to the receiver. Echo sounder is so sensitive that it can measure the time difference of 1/400th of a second. Once the depth is measured, the next step is to measure the average velocity in each vertical of the channel. To do so, current meter is used. This is a cup type current meter, very common in use when current velocity is high. This vertical axis meter can prevent sediment-laden water from entering the bearings. But in addition to the horizontal velocity, it will also measure the vertical component of velocity. This is a propeller type current meter. This is better suited to measure horizontal velocity. But its blades can be damaged by abrasion. This current meter, smaller in size, is used to measure low velocities. To measure the velocity in very small discharges and in laboratory work, the digital low-speed probe current meter is used, which gives velocity directly. In all the current meters, electric current is passed to the wheel, which on rotation, due to flowing water, makes and breaks a contact and produces the ticks and clicks sound, which is heard by the observer through headphones. Suppose the number of revolutions per second worked out to be n, then velocity v will be a plus bn, where a is the starting velocity to overcome friction and b is a constant of calibration. The meter is calibrated periodically. To measure the velocity in shallow waters, the current meter is supported on a graduated wading rod, which rests on the bed of the stream. For measurement in deep water, the meter cable is suspended by a cable and a heavy weight at the bottom that keeps the meter cable as nearly vertical as possible. The heavy weight is a streamlined body which has the shape of a fish and has fins. But at high velocities, the meter cable and weight may not be vertical below the point of suspension. Correction is to be made to obtain the correct depth. In general, the stream velocity varies approximately as a parabola from 0 at the channel bottom to a maximum at the water surface. It has been established that the average of the velocities measured at 2/10 and 8/10 depth below the surface is a measure of the mean velocity in the vertical. The velocity at 6/10 depth below the surface is also a good measure of the mean velocity in the vertical. Therefore, after finding the total depth in a vertical, the current meter is then fixed at desired depth and the number of impulses counted in a time of about 1 to 2 minutes. From the elapsed time and the calibration of the meter, the mean velocity is found. The average velocity along the vertical multiplied by the area of the vertical section gives the incremental discharge in that vertical section. The sum of such incremental discharges gives the total discharge. When velocities are excessive and the rivers are too wide, the use of current meter becomes difficult. Then the float method is used. This is the most simple and economic method. In this method, surface velocities are estimated. For the measurement of velocities, 3 sections are marked across a straight and uniform reach of the channel. The distance between the sections is 100 to 200 meters in case of large rivers and 15 to 30 meters in case of small canals. The float is allowed to drift with the current after its release at a convenient starting line. The length of the float run should not be less than 5 times the width of the channel. The travel time should be around 20 seconds. The time taken by the float to traverse a known distance is measured by the observers on the bank, and the velocity is determined. Instead of surface floats, empty canister properly weighted, sealed and colored to detect its position are also used. But while calculating, suitable correction factors are to be applied to the measured velocity for the shape, size and density of the float. The total discharge is obtained by summing the discharges through all the vertical sections, as is done in case of current meters. Since the velocity varies along the vertical, measurement of surface velocity only is not sufficient. Therefore, velocity rods or lassie rods are also used, which measure mean velocity of the rod. The actual depth and velocity measurements take a long time. The discharge may vary from day to day and from season to season. So, for quick and qualitative estimates of changes in discharge, some kind of gauging devices are used. A staff gauge consists of a vertical scale made of wood or usually of enamel iron with graduations in feet or meters divided into decimal parts attached to bridge pier or other structure. With the help of this gauge, variations in water level are measured with reference to some arbitrary zero datum of the water surface at a station. The height thus registered is called water stage. The manual gauges have to be read frequently to relate the reading to discharge. This is particularly important when the river stage changes rapidly as during floods. In many situations, float type water stage recorders are generally installed in a reinforced concrete shelter house and stilling well on the side of a bank to get the information at close intervals. In a continuous chart recorder, the motion of a float moves a pen along a long strip chart. Mechanical or electrical clocks move the pen from left to right and can be adjusted to make the observation for a desired time. Periodic measurements of discharge with current meter and simultaneous observations of stage provides the useful calibration curve between discharge and the stage. Such a calibration curve is called a rating curve or stage discharge relation. In mountain torrents with numerous boulders and in small streams, discharge measurements with current meter gauging is difficult. In such conditions, chemical methods are used. In this method, an easily measurable chemical which is not present in the stream or not lost by chemical combination is used, such as common salt, fluorescein dye or a radioactive material. A team is going for the discharge measurement by a radioactive material in Tones River. Balloons are released and simultaneously a volume of the tracer of known concentration is injected instantaneously. Balloons are used to identify the arrival of tracer. Samples are taken on both the banks of the river. These samples are taken into the laboratory where on concentration analyzer samples are analyzed and then by calculation discharge is determined. The main disadvantage of the dilution method is the difficulty in determining the section at which complete mixing of the tracer has taken place without loss of the tracer. For small discharges in streams, channels, canals, tube wells, and laboratory models, flow measurements can be made with gauging installations, which works on hydraulic principles. These structures are weirs or flumes. The weirs can be notches of various shapes, rectangular, trapezoidal, and triangular or V-notch. The angle of V-notch can have any suitable value, though the common value is 90 degrees. These are thin plate weirs, and the plane of the notch is perpendicular to the direction of flow. From hydraulic principles, formulae have been developed relating discharge and the head over the crest. For rectangular and sharp crested weirs, the discharge is directly proportional to the hydraulic head raised to the power of 1.5 and to the length of the notch. Hydraulic head is measured by pitot gauge. For V-notch, the discharge is proportional to the hydraulic head raised to the power of 2.5. However, for reliable results, some precautions are to be taken in the installation of weirs. The approach channel should be rectangular with smooth vertical walls. The edge of the notch should be sharp and rigid and made of non-corrosive material. The head of the water should not be measured too close to the notch. In this program, a number of methods have been discussed for discharge measurements. Accurate measurements of discharge over a period of time are also required for building permanent hydraulic structures such as spillways, dams, barrages, and bridges. We are sure that you will appreciate the need for accuracy in discharge measurements.
Measurement field done in the field. Okay. Whatever that morning I explained to you, that has been shown in a movie or video sort of thing. So if you have any queries, let me know, please. Okay. So note that these are still old methods. Okay. But presently, technology has been advanced because this is around more than let us say 25 years old. Okay. But basic principles, they are same only. Okay, but only that because of the sophistication or advances in technology, yes, a lot of new things have come, because earlier there were no sensors at all. Here, no sensors have been shown there. But nowadays, we are using sensors for all the things. Even water movement is also can be uh, seen or can be measured using the sensors. As you are aware, sensors can measure the quality of that water also. Whatever that water quality parameters are there, that also can be measured. Similarly, even in soil sensors are there. So all your NPK and other things, yeah, that can be measured using those sensors. So even in your greenhouse also, they will provide those greenhouse will provide with sensors, so that I'll identify what are all the lacunas, or you can say what nutrients it requires and how to feed them. So on its own, it nowadays that AI has also come. Okay, so that intelligence which you are training to that computers, that will take care of these aspects. I think one class was there on AI and ML. Okay, so that will sense if some field is there, water scarcity is there, then suddenly it instructs, okay, through AI, or you can say that AI is nothing but it helps us. It's a memory. You need to train that one. Okay, so that says that, yeah, here water is less. We need to provide the water so that the tap will open and that water will be fed into that area wherever that agricultural fields are existing. Okay, or if excess water is there at some other place, some other field. Okay, that says that lot of water is available, then you don't provide the water. Okay, so in that way, yes, a lot of technologies have been emerged, and also I think the semiconductor technology is yeah, widely used in throughout the world, and that is cost relatively it is less expensive nowadays. Okay, one thing is, yes, we need to apply this technology, and we need to educate the farmers, strictly speaking, okay, so that all your whatever that greenhouse management which you people are doing, okay, uh, naturally it can be done using these latest technologies. That's what just I wanted to add to this video which I just shown it to you. As I said, it is almost 25 years back video. Okay, but the basic principles are same. One thing is because the technology is advancing every day. At that time, there were no computers at all. For your information, okay, there are no computers. Even when we were studying, okay, hardly one or two computers were there. उसको भी झगड़ा करना पड़ता था. वो कैसे ऑपरेट करने के लिए nobody was there, and that was no word, no Excel, nothing at that time. Okay, it was like a electronic typewriter at that time. Okay. But later on, yeah, day by day technology is improving. Yes, we need to implement these things in field actually. I think yeah, that professor is not there. So we visited some of the universities, like I'm just giving an example of Australia. That university, yeah, they are using all this technology on fertilizers. They are providing it through fertigation, that sensors under the sun. That everything will take care of on its own. No manual intervention over there. Hardly one scientist will be there for the big field. Actually, I think yeah, you might have seen that mechanization, particularly in developed countries. Okay, India, it is labor is cheap, but if you go outside, okay, you'll find that even this providing water, providing fertilizers, all the things will be done by either robots or maybe machines. Okay, and if you go to the other countries like France, he is the owner, he is the laborer, he is everything. Only one guy will operate entire thing. Yeah, that's what. One guy, you can't identify whether he is a laborer or an owner. He is everything. Even ladies also, they are very strong, and they used to work like us only. So yeah, one is laborers are highly too costly over there. There are no drivers existing like in our universities. No driver, nothing. Okay. If he is the vice chancellor, he has to ride. Even vehicle will also be not of universities are like that. It will be a that laborer, okay, sorry, that vice chancellor, he himself drives, and no one is there to carry your luggage or like that. No way. Okay, everything is self this thing. Okay. And of course, even I think you people might have experienced food and other things. Everything is readily available. Okay. Only thing is, yes, you can purchase it on your own. No, even in the shops also. Hardly one guy will be there, or at the most, maybe one assistant may be there. Everything will be done by you only. Self, uh, you need to select it, you just press it, that will identify. And through sensors, that things will be displayed. Okay. I think India is also coming up, but not to the extent what how technology has been established over there. Okay. That's the thing. So any queries are there on this video? Let me know, please. Or if any further. As I said, it is old video. Okay. So some of those who are interested, they can develop this one further, and you can make it advanced also, provided if you have some facilities on there, particularly some media guys, no, you can do it. This is what just I wanted to show it to you. Actually, I was thinking of taking it to the field because of this thing, because this is also video only. I don't know whether you liked it or otherwise, but in the field also, you'll face problems definitely in the field, but that we can overcome those problems and you can do the things. You take the case of your greenhouse system. Operation of that one is here. Many people are available, but not in other countries. Developed countries, no way. Okay? Only Asian countries you can get this one. Okay? Even we visited Russia also. Really, they are advanced like anything. It's one thing is like a curtain. They are not exposed to the other world. Yeah, but by sitting such a big room, one guy was sitting, he used to observe entire field, which area is not fed by water, okay? Which area is fed by water. The all sensors are, it indicates in a uh, just a display. Okay, you can focus it on display. You can identify which disease is there, or which fertilizers he has to provide, or where pesticides needs to be put it into. That's possible. Here we are saying greenhouse is a closed one. There is no question of closing another thing. It's open. Okay. So that way, yeah, things are established, and one should see that atmosphere. That's why we are promoting these exchanges and other things, so that don't be a frog in a pond. You should expose to the outside world so that you'll come to know where exactly you are. Okay. Yeah, any queries, please? Just a small thing, I just shown it to you, and even I just taught it to you. Okay, so you are free to put queries. And not that, yeah, there are separate postgraduate degree, PhD degrees going on just water management aspects itself, or greenhouse management itself. Lot of work is going on. Same thing, technology, they are transferring the technology. It is not just reading at your office or at your class, but that should be transferred to the real field. Then only it has value. So that thing, India is lagging in those fields actually, but yeah, it requires some time regarding that one. Yes, please. Any other issues? This one is IIT Madras has prepared this initiative. Students, Okay, any information out of the track or on the track also? Okay, if nothing is there, I just introduced to some of the aspects of the water and its importance in this greenhouse management. As I was saying, water is one of the component of your greenhouse management. There are many other issues, okay, other factors which also affects that greenhouse, okay, because as you are aware, soil is another aspect which you need to look it into. I am not an expert in soil science or soil part, but water, I just introduced to you how why water needs to be studied and what are its importance and other things in brief. Okay, and of course there are other meteorological factors that also needs to consider for the growth of plant. That means that you must get a good yield, optimized yield you will get it based on these factors which we just saw, particularly in case of water. So thank you for this thing.